So we're going to leave the categorization systems behind now and the different types of definitions. There are many different definitions which are within the CIM best practices, but it can be very long-winded to simply repeat each of those definitions within this presentation. So if those are of particular interest, then it is recommended that the CIM best practices are downloaded and then the reader can go through each of those definitions in turn to make sure they're comfortable with them if they are using those on a regular basis. So let's have a look at the next chapter within the CIM best practices now. We're going to look at the resource database in particular. So within the resource database, the Canadian Institute of Mining, Metallurgy and Petroleum defines two main types of databases that may be stored by a company. The first database is the primary data, and these generally are information that has been taken directly from physical measurements out in the field. And there's all types of primary type of information that may be collected and stored directly into a database of some sort. These include a lot of information in respect to drilling and channel information, where someone is physically going out and taking a direct measurement out in the field and recording that and saving that within a database. For example, collar coordinates would be a direct physical measurement where someone will go out and survey the collar coordinates, an X, Y, Z coordinate system, and store that in the database. Similarly, survey data, the bearing and the dip of, say, a drill hole or a channel as it's taken across a face, these are also direct measurements to be stored. Assays are also direct physical measurements. Though they're taken in the laboratory, they are direct measurements taken from equipment, various types of assaying equipment which are used in the laboratory. They're generally stored and then sent directly to the operation for storage in their databases. Also geological observations, so logging out in the field, and also mapping information, face mapping, anything where a geologist is looking and taking direct observations from the data in the field and then entering that data so it can be stored and used later in any type of interpretation. And also bulk density is of particular importance. So again, often a physical specimen will be taken either underground or from drill core. It's then taken to the laboratory and a density measurement is often taken by measuring the weight in air and water and working out the subsequent density. Density is an important factor as the assays, in that it provides a direct measurement for us to be able to estimate and evaluate the tonnages which are going to be mined from underground. Therefore we need sometimes both observations for ore material as well as waste material to know how much of tons we're going to need to extract and move to be able to allow us to mine the ore. Now the second type of data is interpreted data. So this is normally information which is derived from the primary information. So it's not something which we immediately physically take a reading from the field, but it's something which we begin to generate once we have that primary data and we're beginning to make some types of interpretation and evaluations based on it. These can be such things as geological projections, so we can do cross sections and long sections where we're defining and drawing the different styles of geology or mineralization based on the primary data, drilling or channel data or face mapping. The wireframes that subsequently get generated and performed, these again will need to be stored in some type of database or some type of format where we can recollect those at a later date and use them within our modelling process. The block models themselves are also secondary forms of interpreted data. They are often reliant on the wireframes, the geological projections, and all the primary information which we've initially collected. They're the sort of culmination of all the information that we've gathered, all the interpretations which we've made to finally form the block model, which will then be used in terms of evaluating the value of the ore and whether it's a viable project for us to be able to mine and make money from the operation. So within Fortuna we have a complex setup in terms of our databases. We have a corporative SQL type of database, and from that we are gathering multiple different forms of information and storing that within our database. So generally we have two forms of database where we're collecting that information for each operation. We have a channel database where we're collecting all the information from the samples which are being taken inside the mine. Any type of channel information is stored within there, and any type of quality assurance, quality control information which is used to monitor and ensure that information is relevant and unbiased for our evaluation purposes. It also collects information for drilling as well, a separate drilling database. There we have all the information for both infill and exploration drilling, where we're collecting that data, the geological information from the logging process, and also the laboratory information which is being stored and imported once we get the assay results sent to us from the laboratory. And additionally we're also saving topographic data, or in this sense the collar survey information. So the surveying is also an important part of collecting that data. This is all tracked within the database. There's validation processes which are set up within the Fortuna database to make sure that the data entry is reasonable and there are no errors which are introduced as part of that process. And it also has quality control components which allow checks on the data to ensure that there is no biased information or errors which are being introduced once that information is stored, and trying to ensure that it is as representative as we can make possible of what we're actually seeing and experiencing underground. So once we have that database information, we're then exporting that into various components which are allowing us to then use it as our secondary set of information databases. So out of the corporate Fortuna primary database storage, we're then using that data to generate 3D interpretations, visualizing what type of samples we have above the cutoff. We use such additional software such as Datamine to do visualizations, 3D generation of models, and all the way through their actual plans for the plant, and creating sections and long sections to check that our block modeling matches up with our input data. Additionally, exploration geologists and planning geologists are also using systems such as GIS and CAD to create plans, sections, maps to allow them to be able to improve their data processing and target where they're going to do additional exploration and work which is going to be required further in the future. So the CIM provides some level of guidance in terms of its expectations of what a database must provide to the company. Firstly, it must it must provide a permanent record of all the data collected. So as data is collected as time proceeds, no information should be deleted from that database. It should be a permanent held record, due to the fact that at certain times people may believe that certain records are of no use and feel that that to clean the data they can delete records, but these opinions may change over time, and those records may be required in later years, and therefore it's no good if that information or data is deleted. So once information has been put and stored in that database, it should be kept there permanently. It is important to date the databases in terms of when they are being used for particular pieces of work. For example, as part of the mineral resource, mineral reserve evaluation process, the date for the data cutoff, which is used for mineral resource evaluation, is June 30th each year. At that time, a copy of the database is taken and permanently stored and recorded within the data files, so that if and when someone would like to reproduce the work which was undertaken, they have a snapshot of exactly what was available at that time. So when that database is recorded as of that date, the date that cutoff is made should be recorded and shown clearly with those databases. In terms of the usage of that data, when a QP or a geologist or an engineer is using that information, they should record what their comments are and whether there's any shortfalls, any issues, any errors in terms of that data, so that it is clear whether there is any potential problems with the primary data or secondary data in the evaluation process. That often is comprised of a series of observations and comments held within a technical report, or if a technical report is not used, then an internal document to state that the QP has looked through the database and feels comfortable with its usage, and that any errors or any issues have been looked at or addressed, or certainly there are some comments to indicate what any of those types of problems might be. It is also important that that information is stored and is available for future reference. So, as I say, in terms of the date of the cutoff of data, a snapshot of that database is held and kept for any type of future usage. So if anyone would like to go back and repeat the work, there is an easy process to doing so by taking that snapshot and reusing the database as of that date. From that point onwards, the database itself will continue to gain additional information, so it's important that a snapshot and a copy of that database is taken when a particular process is being performed. A fourth point that the CIM makes is that it is important to provide all the information necessary to enable current and future geological interpretations and modelling. So again, it's important that there's no information which is discluded that isn't going to help the interpretations, particularly around the geologing process. So really the resource database is very much set up to expedite and assist the geologists in being able to model as best as they can the geological interpretations which is occurring underground or on the surface. The CIM also recommends that this data is to be stored digitally using a documented standard format and a reliable medium that allows easy and complete future retrieval of the data. So in this day and age where there are a lot of different types of databases available, all the way from fairly simple access databases up to through more complex SQL. Even though it's not recommended, an Excel spreadsheet could be regarded as a database in some capacity, although it has a lot of frailties and generally is not recommended. There is no reason why this information should not be stored digitally as of today. In previous years, a lot of this would have been documented on paper format and held in various storerooms, but now a lot of this material can be scanned or it can be transferred into a digital format, which allows this information to be stored from this point moving forward and additional information added, and various backups can be made to ensure that the data is securely held and therefore is unlikely to be destroyed, mishandled or lost in the future.